In this lesson, we will identify zeros and the multiplicities of zeros. So we know that if we are to graph a function, the solutions are sometimes called zeros, or they might be called roots. So all of those things mean the same thing. A solution, a root, a zero, etc. They all mean the same thing. They're also known as the x-intercepts. So that's essentially what we're going to try to do, is try to find the x-intercepts of the function. Easier said than done sometimes. Now, if I want to find the zeros of the function, there are different things that I can do. The first tool in my toolbox is I might, because this is 4 terms, I might try to factor this, because I know if I'm finding the zeros, I'm replacing f of x with 0. So I'm saying 0 equals, and then I'm going to try to factor by grouping. GCF of those two terms is x squared, which leaves me with x minus 5. GCF of these two terms is negative 16, which leaves me with x minus 5. So lucky me, I chose correctly right away, because if I divided this by negative 16 and this by negative 16, I get the same thing that I had over here. That means 0 equals, these two values come together, so x squared minus 16, and then x minus 5. I'm going to keep factoring because I have a squared value. X squared minus 16 is a difference of squares pattern, which means that's x plus 4, x minus 4. Keep that x minus 5 in there. So now I have 3 binomials, and I know that because my initial question was to the third power, I have up to 3 zeros, up to 3 roots. My 3 roots would be setting these equal to 0. So if I said x plus 4 equal to 0, I get x equals negative 4. If I said x minus 4 equal to 0, I get x equal positive 4. And if I said x minus 5 equal to 0, I get x equals 5. Those are my roots. Those are my zeros. Those are my solutions. They all mean the same thing. So the zeros of the function are negative 4, 4, and 5. Go ahead and do this one. You can try to work ahead of me if you would like. Again, I would do the same thing here. Because it's 4 terms, I would try to factor by grouping. I'm finding the zeros, so I'm setting f of x equal to 0. I would take a 4x squared out of both of those terms, leaving me with x minus 1. Out of these terms, I would take out a negative 25, which would leave me with x minus 1. Again, that leaves me with 4x squared minus 25 and x minus 1. This does turn out to be a difference of squares pattern again. 2x plus 5, 2x minus 5, x minus 1. Again, difference of squares because I had a perfect square here. The square root was 2x. A perfect square here. The square root was 5. And there was a minus in between. You have that difference, or you have the cheat sheet for factoring that's in, I believe, your week 2 and your week 3 folder. So if you don't have that printed out, I would go ahead and do that. To find the zeros then, I'm going to set each of these equal to 0. So that would give me negative 5 halves, positive 5 halves, and positive 1. You can do that work in your head by setting those 3 binomials equal to 0. Here's another one for us to try. Now, first impulse of a lot of students would be to multiply all of this out, and that would just be a really bad decision because that's going to make it way more difficult. So to find the zeros, I'm going to set this equal to 0, and the good news is they have already done all of the factoring for me. Now notice I could have 1, 2, 3, 4, 5, 6, so I can have 6 zeros in this case. So 1x here, this is an x squared, this is an x cubed, so that gives me 6 x's. Now if I set 8x equal to 0, I divide each side by 8, I get x is 0. If I set x minus 1 equal to 0, I would add 1 to get x is 1, but there are 2 of them. So that means this solution has a multiplicity of 2, meaning it happens 2 times at x equal 1. My last one, x plus 3 equals 0, I would subtract 3 from each side and get x equal negative 3. But that happens 3 times. So instead of writing it out 3 times and doing the work 3 times, I say this has a multiplicity of 3. Now, multiplicities will make more sense once we start to graph as to why those are important. Go ahead and find the zeros of these functions and then press play to check your work. For the first, again, I'm replacing f of x with 0. I would start with a GCF here and take an x out of all 3 terms, which leaves me with x squared plus 10x plus 25. I would then factor. I'm looking for numbers that multiply to 25 that add to 10, which would of course be 5 and 5. Positive 5 and positive 5 means basically this is my factorization, but this is the same. So I would write this as x plus 5 squared. So in finding the zeros, so this is just the factorization. To determine the zeros, I would set x equal to 0 to find that x is 0. And I would set x plus 5 equal to 0 to find that x is negative 5, but that has a multiplicity of 2. 2 values of negative 5. On my other, I would start by taking out 2x to the 4th, which would leave me with x squared and minus 7. By setting 2x to the 4th equal to 0, I would divide each side by 0. I would take the 4th root, which is 0. So I have x equals 0 4 times. So 0 with a multiplicity of 4. Setting x squared minus 7 equal to 0 gives me that x squared is 7, which means x is plus or minus square root of 7, which is 2 separate answers, radical 7 and negative radical 7. So I have 0 with a multiplicity of 4 and then 2 other solutions.